So here we have our last example problem for this particular section of the chapter. We are looking at the fact that we have a given mass. We do see that it stretches some particular amount when we hang it from a spring. We want to know what is the period of motion for this particular mass spring oscillator. So let's go ahead and take stock of our knowns and unknowns. So we went ahead and look at that mass, that distance of stretch and compression. We want the period. Because we know this is a mass spring oscillator, we're supposed to be using this equation down here at the bottom. However, we're missing one piece. We're missing the spring constant. We don't know what that K value is going to be. However, if we go all the way back to chapter 5 with the information we covered there, we can actually see the fact that we can find it. We are hanging this vertically. As a result, we are then able to pull information from Hooke's law that F is equal to Kx. In this particular instance, we are going to look at what is the force. Well, the force is the weight of the mass itself. So this is going to be equal to mg in this particular case. When we go ahead and solve this equation for the variable that we want, in this particular case, k, is equal to my F, which is mg, divided by my amount of stretch. Everything that I need is actually already in its base units, so when I go ahead and find k, I am able to plug and chug without having to make any adjustments. Alright, so of course when we plug and chug that particular information, we do get the fact that K is equal to 4.9 newtons per meter. However, as you recall, this is not what we are looking for. We are actually looking for period. Right? But we do have K, we do have M at this particular point. We can plug and chug for our last round of information. Alright, so we are pulling that information from our problem, that 0.10 kilograms, the 4.9 newtons per meter we just solved for. Plug it into our calculator, we do get the fact that the period in this particular case is actually 0.89759. It's a bunch of numbers. If we are going to go ahead and round that down to 3 sig figs, we are going to see that it's 0.898, and that's in seconds, because remember it's period.